Imagine a car that costs less than many high-powered motorcycles, but still carries the Tesla name stamped on its hood. This is precisely the promise of the upcoming Model 2, which will arrive with a starting price of $15,990. Interestingly, even at this low price by the brand's standards, it won't abandon the DNA that has won Tesla so many admirers around the world. The idea is to deliver a subcompact crossover inspired by the Model Y and Model 3, but with that bold twist reminiscent of the Cybertruck, a car that will be born with the mission of being urban and practical, and that could even be offered in a hatchback version to conquer demanding markets like Europe and China, where this format is practically a national passion. Visually, it will feature more compact proportions, but without losing the clean lines and modern features that Tesla has already established. It's possible to imagine a design that, at first glance, will make any fan recognize the brand, but with a touch of youthfulness to attract a new audience. And that's precisely the point. Elon Musk knows there's no point in creating a cheap car that looks cheap. The strategy will be to deliver something that inspires desire, while also being affordable for those who've never dreamed of owning a Tesla. It may not have futuristic doors that open upwards, or a dashboard that resembles a spaceship, but it will have enough presence to make a statement on the streets. The choice to create a crossover instead of a pure hatchback is also no accident. In the United States, this type of car dominates sales and conveys that sense of robustness that the average consumer loves. At the same time, there's nothing stopping Tesla from introducing a hatchback version in the future, for markets where urban agility and easy parking are more important than ground clearance. This duality of styles could significantly expand the model's reach, creating a range of options capable of winning over customers from very different automotive cultures. An interesting detail is that, despite being compact, the Model 2 will strive to convey the feeling of being behind the wheel of a real Tesla. This means it should inherit some features from its more expensive siblings, such as the minimalist cabin experience and, possibly, the multimedia center dominating the dashboard. No more buttons scattered everywhere. And if Tesla follows its own track record, it's quite possible that even the cheapest version will feature some form of autopilot, reinforcing the image that the brand isn't just selling cars, but rather a glimpse into the future. This appeal will be essential to differentiate the Model 2 from its direct competitors, which, despite being cheaper, fail to convey the same sense of innovation. After all, it's not enough to just put a battery and an electric motor under the hood. The car needs to tell a story, and Elon Musk understands like few others the importance of transforming a product into a symbol. That's why the Model 2 will be launched with the ambition of being not only the cheapest Tesla, but also one of the most relevant to the brand's image. It's worth remembering that Tesla will still have to balance public expectations with the natural limitations of a car in this price range. The challenge will be maintaining its charm without making the project financially unviable. A smart solution would be to make the most of existing parts and technologies, adapting what works in larger models to a more compact and affordable format. It's a chess game, and Tesla will need to move its pieces carefully to avoid compromising either the car's quality or appeal. For the Model 2 to truly become the revolution it promises, Tesla will need more than an attractive design. It will rely on a solid foundation, literally. The strategy will be to leverage an existing platform, something that will not only accelerate development, but also cut engineering costs. Instead of creating everything from scratch, the brand will borrow solutions already used in the Model Y and Model 3, adapting them to the car's new size and profile. It's like taking the skeleton of a seasoned athlete and reshaping it for a new sport, maintaining strength and efficiency, but adjusting the shape for a different game. The initial plan is to begin production at Giga Texas, which will become the Model 2's maternity ward. There, Tesla will apply all the knowledge accumulated in the Model Y and Cybertruck lines, but in a more compact format and with even more optimized processes. The goal is ambitious: to reach 10,000 units per week, For the automotive industry, this is the equivalent of putting a rocket on the ground every day. It requires pace, precision, and impeccable logistics. And, knowing Elon Musk, the ambition won't stop there. Once production is consolidated in the United States, the idea will be to expand the Model 2 to other strategic factories. China is practically guaranteed to be on this list, mainly due to its mass production capacity and lower operating costs. Tesla knows that for a car that aims to reach a global audience, production close to key markets is crucial. This means shorter transportation times, lower logistics costs, and more competitive pricing in each region. There's also the possibility of the Fremont factory in California joining the mix. Although older, this plant already has a well-established infrastructure and could accommodate the Model 2 without major structural changes. The advantage would be leveraging an already trained workforce and an established supply chain, which would help avoid delays and issues typical of new production lines. However, any decision in this regard will depend on the car's initial performance and the demand it generates. A crucial detail to achieving the desired scale is the application of Giga Casting, the single-piece casting process that Tesla already uses in other models. With it, large parts of the car's structure will be molded at once, drastically reducing the number of parts and simplifying assembly. This technology not only speeds up production time, but also ensures greater structural rigidity and reduced weight, which, in the case of an electric car, directly translates into greater efficiency and range. This method will transform the way the Model 2 is manufactured. While traditional brands still spend hours and hours soldering dozens of components, Tesla will have a leaner production line, with fewer steps and less room for human error. This will allow the company to maintain competitive pricing without sacrificing quality. Essential for the public to believe that a $25,000 Tesla is still a real Tesla. Tesla's big move with the Model 2 will be balancing cost and perceived value. The goal will be to manufacture each unit for between $16,000 and $18,000, allowing it to be sold for around $25,000 while still maintaining room for investment and growth. It sounds simple on paper, but in the real world, it's a real financial juggling act. The challenge will be cutting costs without turning the car into a bland or fragile design, while maintaining that sense of innovation and trust that the Tesla name carries. To achieve this, the company will need to be extremely careful in its component selection. High-cost items in premium models, such as some interior finishes and sophisticated sound systems, can be replaced with simpler, more affordable alternatives, but without making the customer feel like they're getting less of a car. It's like preparing a cheaper dish at a famous restaurant. The flavor and experience must remain at the same level, even if the ingredients are more economical. The key will be to maximize the use of technologies and parts already available on the production line, leveraging motors, inverters, and even some of the electronics from the Model 3 and Model Y will drastically reduce development costs. This also improves reliability, as these parts have already been tested and proven over years of use. Furthermore, Tesla will be able to negotiate large volumes with suppliers, securing deeper discounts due to its scale. Even so, there's a limit to how much savings can be made solely through parts and commercial agreements. This is where innovations in the manufacturing process itself come in. The use of Giga Casting and structural batteries, which will eliminate entire assembly steps, will be one of the pillars of keeping production costs low. The fewer steps and fewer parts, the less labor and time required, and this translates directly into a cheaper car for the consumer. Another factor that could weigh in favor of the Model 2 will be the simplification of the range of trim levels and options. Instead of dozens of configuration packages, Tesla will be able to offer a limited number of combinations, concentrating production on fewer variations and facilitating inventory control. This strategy, already used by other automakers for high-volume models, allows for faster manufacturing and less waste. Of course, to achieve this price point, Tesla will also have to make bold choices. The car will likely lack some features considered standard on more expensive models, such as power seat adjustments or premium factory sound systems. However, if the project is well executed, these cuts won't be perceived as a lack of quality, but rather as a focus on the essential, offering a functional, efficient, and reliable Tesla at the lowest possible price. If there's one area where Tesla will bet big to make the Model 2 a bestseller, it's the battery. The choice is expected to fall on LMFP technology: lithium, manganese, iron, and phosphate. An evolution that promises to combine the best of both worlds: reduced cost and reliable performance. Unlike traditional LFP batteries, which are already known for their durability and safety, LMFP will add manganese to the formula, increasing energy density and allowing for greater range without increasing the size or weight of the pack. The impact of this on the final price will be enormous. Studies already indicate that LMFP could reduce battery costs by up to 30% compared to current technologies, which is a huge relief when we consider that the battery pack accounts for about a third of an electric car's total cost. And these savings won't come at the expense of performance. On the contrary, the improvements in energy density should allow the Model 2 to achieve competitive range, sufficient for everyday use for virtually any driver, including longer trips. Another notable feature is the LMFP's thermal stability. Anyone who's ever heard of batteries overheating or losing efficiency in the cold knows how frustrating this can be. The new chemistry promises to be much more stable in different climates, maintaining good performance both under scorching sun and on harsh winter days. This versatility will be an asset for a car that aims to be sold in markets as diverse as Texas, Norway, and China. Furthermore, recharge times should also improve. Thanks to recent advances in internal cell management, LMFP batteries will be able to accept higher charging powers without compromising safety or lifespan. This means less time spent idling at the charging station and more time driving, something that, for many people, will be a deciding factor when making a purchase. Imagine recharging from 0 to 80% in just a few minutes while enjoying a coffee or running a quick errand. This will be the experience Tesla aims to deliver. There's also a strategic aspect behind this choice. By adopting LMFP, Tesla reduces its dependence on expensive and difficult-to-obtain metals, such as cobalt and nickel, used in other battery chemistries. This not only reduces the company's exposure to price fluctuations in the global raw materials market, but also strengthens its sustainability and social responsibility narrative, something increasingly valued by consumers. Of course, this transition won't simply be a matter of swapping one material for another. Tesla will have to adjust its production line and validate the new chemistry to ensure it meets durability and reliability expectations. But given the company's track record of accelerating technological developments, it's not difficult to imagine that the first prototypes with LMFP are already in advanced testing, gathering data for fine-tuning before launch. Tesla won't stop at choosing battery chemistry. The next leap will be to transform the cell assembly itself into a structural part of the car. In the Model 2, the battery will not only be an energy tank, but also part of the chassis, taking on functions previously performed by separate metal components. This approach, called a structural battery, will eliminate redundancies, reduce weight, and simplify assembly in a way few automakers in the world can achieve today. In practice, this means that the car's floor will be the battery itself. Instead of assembling modules and then fitting them into a frame, Tesla will integrate the cells directly into a rigid structure that will form part of the vehicle's base. This solution not only reduces the number of parts, but also increases the rigidity of the assembly, improving safety and even dynamic performance. After all, a lighter, firmer car responds better to corners and consumes less energy to move. The efficiency gains in the manufacturing process will also be significant. By integrating the battery and chassis, Tesla will eliminate entire assembly steps, saving time and resources. This is especially important for a model like the Model 2, which will need to be produced in extremely high volumes to reach its price target and meet global demand. Less time per car means more units rolling off the line every day. And this, combined with reduced costs, is a powerful recipe for dominating the segment. The use of Giga Casting will fit perfectly into this concept. While the structural battery takes care of the central part of the car, Giga Casting will mold the front and rear sections from single pieces of cast aluminum. Ultimately, the vehicle will consist of just 3 large structural blocks: the front, the base, with the integrated battery, and the rear. This simplicity will completely change the production process, compared to the traditional method that uses hundreds of smaller parts. This engineering will also be reflected in the design and user experience. With fewer components taking up space, there will be more freedom to optimize the interior, improve ergonomics, and even increase trunk capacity without increasing the car's exterior size. This is especially valuable in a subcompact crossover, where every inch counts. Another positive effect is the weight reduction, which will directly translate into greater range for the same battery capacity. In a market where consumers still care about how many kilometers they can drive before recharging, any gain in this regard is welcome. And best of all, this will be achieved without increasing battery capacity, keeping costs under control. The Model 2's success will depend not only on technology and design, but also on where and how it will be produced. Tesla already knows that, to maintain a competitive price, it cannot manufacture this car exclusively in the United States. The strategy will be to think globally from day one, choosing locations that offer not only an efficient workforce and cutting-edge infrastructure, but also proximity to the most promising markets for electric vehicles. Everything indicates that China will be a pillar of this production. Giga Shanghai has already proven itself to be one of the fastest and most efficient factories in the world, assembling a Model Y in under a minute. Producing the Model 2 there will mean lower costs and shorter delivery times, especially for Asia and Europe. Furthermore, the Chinese supply chain for batteries and electrical components is extremely mature, which will reduce delays and supply risks. Giga Texas will continue to be a strategic hub, not only for supplying the American market, but also as an innovation laboratory for assembly processes. It is there that Tesla will test and fine-tune its Giga Casting, structural battery, and automation solutions before applying them on a global scale. Initial production in the US will also help Tesla win over domestic consumers, who tend to value domestically manufactured products. There's also the possibility of the Fremont plant entering the mix. Despite being an older plant, it boasts experience, a trained team, and nearby suppliers. If demand for the Model 2 explodes, Fremont could be used as an additional line to relieve pressure on Giga Texas and Giga Shanghai. However, this decision will depend on the balance between production costs and required volume. Europe is also a tempting market, but cost is a barrier. Producing in Giga Berlin would ensure proximity to European consumers and reduce import duties. But the higher labor costs could jeopardize the goal of maintaining an affordable initial price. Therefore, Tesla may prefer to export units from China to Europe, at least until sales volume justifies local assembly. This decentralized production vision will allow the Model 2 to reach the market with prices tailored to each region, taking advantage of local tax incentives and avoiding excessive transportation costs. At the same time, Tesla will maintain the standardization of essential components, ensuring that, regardless of where the car is manufactured, the driving experience of a Model 2 is always the same. If global production is to ensure the Model 2's presence in key markets, Optimus robot technology could be the trump card for manufacturing this car in unprecedented volumes. Elon Musk has already made it clear that Tesla's long-term vision includes near-total automation of several stages of the assembly line, and the Model 2 will be the perfect platform for this transformation. These aren't just industrial robotic arms, but humanoids capable of performing complex tasks, adapting movements as if they were experienced workers. These robots are already being tested in factories like Giga Texas and Giga Shanghai, performing simple but repetitive tasks like moving parts, attaching components, and inspecting quality items. The big advantage is that they don't need brakes, don't tire, and can operate with constant precision, reducing errors and rework. With the arrival of the Model 2, Tesla plans to scale this presence, putting hundreds or even thousands of Optimus robots working alongside humans. The impact of this on production costs will be immediate.